So on the AP exam, you'll need to predict reactions. You will be told what the reactants are in terms of just their names, and you'll need to predict how they react after writing out their proper formulas, how they react into certain products. And so it's best to kind of classify reactions first. Here we'll just talk about three main types: combination, decomposition, and combustion reactions. So combination reactions involve combining elements together. So aluminum metal, as an example, is submerged in liquid bromine. All right, aluminum metal, Al, and then you can write solid, is submerged in liquid bromine. So let's see, bromine is Br, and it's liquid, but hold on. Bromine by itself is not just Br. This is one of those 7 diatomic elements. It's Br2. So what do you get when you combine aluminum and bromine together? You see, you're probably going to have some kind of oxidation reduction reaction. These guys won't stick to each other unless there's some ionic charge holding them together. And so let's see, what is the only charge that aluminum can get if it's charged? It's going to be Al3+. And bromine can have several oxidation states, but it can only have one charge and stick to another ion. Its only charge is -1. So when you combine aluminum and bromide now together, you'll get AlBr3. And that's likely to be a solid, as almost all ionic compounds will be. So you need to balance these equations. You get certain points for just writing the correct reactants, and you also get points for balancing whatever equation it is that you write. So let's see, we have 3 bromines here and we have 2 bromines here. The lowest common multiple of 2 and 3 is 6. And so you need 6 bromine atoms on each side, so you can put a 2 here and a 3 here. And now to balance aluminum, we have 2 aluminums, we have 2 aluminums. Next, sulfur is burned in air in order to form sulfur dioxide. So sulfur, that is a solid on its own, yellow solid. It reacts in air. When it's burned, that's a good keyword that it's reacting most likely with oxygen, but sometimes nitrogen as well. Sulfur will react with oxygen in order to form sulfur dioxide, sulfur di 2 oxides there. Let's see, so you'll have a gas as O2, and actually SO2 is also a gas as well. Both small molecules will be most likely gases. All right, and so I guess, do we need to balance anything? No, this is balanced as is. Only thing is, be careful about writing O2. This is one of those diatomic elements. Now, decomposition reactions involve taking one compound and turning it into many compounds, or at least 2. So when you decompose elements, good key words are that they are either heated or it's done under vacuum. And very often, if you have decomposition reactions, you're going to get these gases. You're likely to get O2, CO2, H2O, NH3, or SO2, or sometimes 3, depends. Okay, so Mercury 2 oxide. So Mercury has a charge of 2+, and oxide, you know, is 2-. So HgO is heated vigorously under vacuum. You can show this using a triangle, a delta. And what do you get when you heat this vigorously? Well, you take one compound and you separate it into many. So I guess most likely you'll get mercury on its own, and you'll get oxygen on its own. However, when you write out oxygen, it's a diatomic element if it has no charge, if it's alone. And so you'll get O2. Now balance, you need 2 oxygens on each side. Now you have 2 mercuries on both sides, put a 2 there. Try next, sodium sulfate. So before writing the compound, consider the ion sodium, and sulfate is 2-. So sodium sulfate is Na2SO4. It's heated vigorously under vacuum. The vacuum reduces the pressure above, and so that enables an easier release of gases. So what gas will you get here? Let's see. So maybe you could release SO2 or maybe SO3. That's one of the gases that you might release. You might also consider O2, but in this case, this is a kind of type of reaction which you'll need to memorize. You're going to release either SO2 or SO3. So considering that, you are going to have sodium left over, and most likely it's still going to be attached to some oxide. Sodium is a very, very reactive metal. If it's a metal, it's likely to react and be oxidized again. So you're not likely to get Na, you're going to have Na+. So most likely that'll be near an O, 2-, and so you'll get Na2O formed. And what's left, if you remove one oxygen from SO4, you'll have SO3. Next problem. Calcium carbonate. Calcium is 2+. Carbonate is 2-. Calcium carbonate, let's see, there's 3 oxygens on carbonate. Calcium carbonate is a solid which you heat vigorously under vacuum. So what gas might you get here? So go back to that list of gases. Do you see any gases standing out there? I see CO2 there. So likely you're to have CO2 released. And so that leaves you a calcium and another oxide. Can you form CaO? Well, yeah, you're not likely to get calcium metal, but Ca2+ and O2-, they will form to give you calcium oxide, and this is properly balanced. Next, ammonium carbonate. Ammonium is NH4+, carbonate is CO3 2-. So to combine these, you need 2 ammonium, so parentheses if there's more than one. NH4, there's 2 of those, and then a CO3. Heat that vigorously. What do you get? Okay, so I see a CO3. That often will decompose into CO2. I see NH4. If that is released as a gas, that's likely to be released as NH3. However, there's still hydrogens and oxygens left over. What's another gas which might be released from that? Try water. And this is balanced as is. These are just kind of things you need to memorize. Memorize those gases, guys. All right, propane is burned in air. Burned means combusted, most likely reacting with oxygen. So propane, we'll talk about the organic molecule soon, but propane is C3H8. So if you wanted to, say, heat some steak in your grill, you might use a propane grill. You're burning C3H8. And so it's burned in air, i.e., oxygen is likely to be a reactant. And so what do you get? When you combust a hydrocarbon, you get CO2, and you get water. Balance. So let's see. You have 3 carbons, so you'll need 3 carbon dioxides. You have 8 hydrogens, so you'll need 4 times 2. You'll need 4 hydrogens. 4 waters. And how many oxygens? Balance that last because there's oxygen and 2 products. Let's see, we have 3 times 2, we have 6 oxygens here, and we have 4 times 1, we have 4 oxygens here. We need a total of 10 oxygens here. How many O2s? We need 5. And this is balanced. Thanks for watching, guys.